What happens when a century-old car maker rethinks the very foundations of its factory floor? That's the question I'm putting to my guest today, live on the show floor here at VMware Explore in Vegas. Now, Audi has been quietly building what might be the blueprint for the factory of the future. And at the heart of that transformation is the Edge Cloud for Production initiative. So instead of relying on thousands of industrial PCs scattered across its plants, Audi is now consolidating workloads into local production clouds powered by VMware Cloud Foundation. So what does that mean? Ultimately, it means less hardware, faster updates, greater resilience, and an even smaller environmental footprint. And beyond the headlines, this shift also changes what's possible on the shop floor. From virtual PLCs controlling robots with millisecond precision to data transparency. Transparency that helps maintenance teams fix root causes rather than just papering over the problems. And my guest today is Dr. Henning Löser. He's the head of Audi Production Lab. And his team are the experimenters, the so-called nerds, as he put it, who push technology into production before most of us realise what's possible. So today we're going to talk about what the factory floor looked like before digital transformation, what it takes to bring IT thinking into OT environments, and why virtualization might be the cornerstone of the smart factory era. And yes, we even get into what happens when a beaver takes a bite out of a fiber optic line. And if that's not enough to hook you in, I don't know what will. So enough from me. Let me introduce you to my guest. So thank you for joining me today. We're talking here at VMware Explore in Vegas. Can you tell everyone listening a little bit more about who you are, what you do, and what you're talking about at VMware Explore this year?
Hi, Neil. Thanks for having me. My name's Henning. I work for Audi for the production of Audi. And inside production, we have what we call the P Lab. And that's a small group, and I lovingly call ourselves nerds, who are there to figure out what new technologies are out there and then think outside the box of conventional production, figure out what technologies could be helpful for us in production, try them out in a lab environment, evaluate them, and try to push innovation into production quicker than it would normally happen otherwise.
And there are so many emerging technologies at the moment, and they're all beginning to converge. And I've got to ask, before your transformation began, what did Audi's factory floor, what did that look like in terms of automation and IT systems, tech stacks, etc.? And what were the main limitations that you were facing there?
Before the project that we started, our production line looked like any other highly automated body and white shop or final assembly lines, state-of-the-art technologies. And basically it's what you now would learn if you go to a mechanical engineering school, study mechanical engineering, and they tell you, hey, this is how you have to set up an automated line, this is how it works. And at the same time, that also is the answer to what are the limitations. I think all of us in manufacturing, we're striving for the smart factory. That's a cool word. What does it mean? And we're learning right now that software progresses much, much faster than our mechanical tools that we use for production. And so our goal was to figure out a way how to set up a production line that is more scalable on the software side. What we did with this project that we call Edge Cloud for Production was to figure out a cornerstone of how do we enable our production lines to adopt new software and use the new software capabilities while keeping the investments of the already installed base of what we have.
And I'm curious, what was it that sparked the decision to rethink how production, IT and automation could be managed? And how did that vision evolve into the Edge Cloud for Production initiative? Is there a story there?
I mean, if you look like over the press releases we did over the last decade or so, we really looked into how can we deploy AI algorithms to optimize our production? How can we use vision-based systems to optimize our quality and our processes? And we did all of these projects and figured out, hey, yes, there is efficiency to be gained, but at the same time, if you install or if you have a project and with a new idea, you hit the environment, a brownfield environment with an installed base, you always run into a problem with, okay, how is the business case if I have to tear out the entire mechanical stuff and redo everything just for a teeny kind of like new, shiny, fancy function? Not wanting to be disrespectful here, but it's in the end, it has to be a business case. All the stuff that we're doing has to be a business case. We want to drive our efficiency. And if that means you have to install new hardware, that's usually cost prohibitive for doing all these steps. So the steps are usually taken slowly. And realizing that, we, in the P Lab, we kind of like took a step back and we decided, okay, let's look at how are other industries doing this? How are other industries coping with the problem of ever-changing software? And that's when we came across the technology of virtualization that we are deploying in our data centers for decades, ever since it's there. But this virtualization technology had not been deployed to manufacturing to that extent. And so that was the birth of the idea, hey, let's take virtualization technology into production and see where does it help us.
And that is such a good point you raise there about that it is all about efficiency, solving a business problem, not getting distracted by the shiny technology. And of course, a major breakthrough has been the use of virtual PLCs. So how does this shift away from hardware-based controllers? How does that shift change how production lines and robots are managed day to day?
Actually, from a production point of view, nothing changes. Yeah. And that's the cool part. So we do not have to retrain our colleagues in production. Everything stays the same. What does change is one tiny hardware box representing the physical PLC today is just not there anymore. What you have instead is fiber optics network connecting our production lines with local data centers in which those PLCs are running. And we have that, and that's the new thing. We have that now with safety. So a SIL level 3 performance level D, sorry for the technicality here, safety certified PLC running on this commodity server hardware, but still controlling and performing the same tasks that our orchestration PLCs were doing before that. And now what do we gain with that? We gain with that all those technologies that have been developed for the data centers automatically apply to this virtual machine that is now running the PLC. So you get auto snapshots. You have the ease of implementing watchdogs that look into your field bus protocol, figuring out, okay, is there malicious traffic in that field bus protocol? We gain ease of updates, deploying new updates, and all of those features that are common in the data centers, that are common in software, in IT world, we get to deploy now in the automation world of manufacturing.
And I'm curious, from the perspective of workers on the line, what has been the most visible change in their daily operations since workloads were centralized into the production cloud? Any big changes there?
We started this whole project with 5 applications, 4 of them being mainly focused, or actually 3 of them focused for the final assembly. So our work guidance system, the MES system, our electronics quality control system, our torque screwing control system. And those are systems that up to now used to run on regular IPCs with displays showing the workers what to do. And we changed those from the IPCs to thin clients. And so what the worker on the line notice is, well, there's a different screen now. You don't have a big form factor IPC anymore. It's just an IPC thin client installed into the monitor. So again, they do not see a difference in their daily work in the very first step. Maintenance sees a difference. If something breaks, they go there, they exchange thin client. But what we did see or do see actually for maintenance is a much higher availability, higher uptimes of those thin clients in comparison to kind of like this bunch of IPCs, because the application running in the server environment always sees the same environment. On the IPCs, it's the same environment. And then over time, you start changing a graphics card because the graphic card broke. You start installing a new network card because something broke there. And so over time, those IPCs, even so you bought them to be one like the other over time, though that this installed base kind of like dissipates. and it makes it really hard to figure out errors. And once in a while, you've got errors like, well, every 5 days, the PC just stops working. Well, the fix is easy. Just like hit the on-off button, reboot it, and it works. Next step is, if you know it happens every 5 days, after 4 days during a regular break, you install an automation system that just reboots the PC and everything's fine. But that's a fix to the problem, but it's not a solution to the problem. And in production, we tend to live with fixes because, hey, that's an easy fix. Let's just do that. But what we do now have is we have the transparency of a hyperconverged infrastructure that tells us, hey, look at this, in this image, all of a sudden the memory is used up over time, or storage is used up over time. Check in that image what's happening there. Maybe somebody enabled a debugging mode and therefore it's hogging its storage space. And having 15,000 IPCs installed, it's hard to know somebody configuring something for whatever reason and then not unchecking that checkbox anymore. Now we have the full transparency of all those IPCs, like on this single plane of glass where we monitor our hyperconverged infrastructure. And just this transparency really, really helps our maintenance people to go and fix the right thing, because we have the transparency of what's happening. And if we see an error like memory is filling up, then we can kind of like do a snapshot and then do the forensics on what's happening here. One of the errors I remember being told by a colleague from maintenance was exactly this graphics card error. For whatever reason, a couple PCs always broke down after a while, and it took really, really a long time to figure out, well, yeah, they had a new graphics card installed. The graphics card driver had a bug that didn't free up memory where it's supposed to. So it kept filling the memory with old graphic card stuff until the memory was full and the PC crashed. And that's something that's really, really hard to find as a maintenance guy. So yes, you do a fix, like, you just reboot it every 2 days, but figuring out, okay, this is the error, this is the problem. Dear graphics card vendor, please fix your driver because this is happening. And this is for me what we strive to do. We strive to have kind of like to fix the problem at the root cause. And for that, you need to have the transparency what's actually happening. And using the VCF suite gives us this full transparency so that we can do things. So this is what we've done in the final assembly. So again, your question was, did anything change for the colleagues? First step, no, nothing really changed. They still get their displays. They get to know what to do. And what really helped is now maintenance has new tools that enables them to figure out what is happening. Now, same thing is also true for the virtual control PCs that we use in our automation cells and for the PLCs. And for that, I like to cite the head of the maintenance in the Böllinger Höfe when we had the launch in March, and he was asked, hey, what changed for you? And he said, well, what really changed for me was this is much easier to fix than in the past. Just thinking about, I come here, I analyze, I see I need to replace the PLC because the PLC is broken. In the old days, I would have to walk to storage, get a new PLC, walk back, unplug the old one, put the new one in, transfer the SD card with the program on it, and have it back running probably in an hour. Today, I just call the operations center and tell them, hey, respawn this PLC, please. It takes a minute and a new PLC is up and everything's running again. So from a maintenance point of view, this was for them was a really big step. And I always think that once the people who are using the technologies that are coming out of the PLab, they really get this gleam in their eye and say, this is really cool, this helps me. That's when we are so successful from the PLab.
And that is such a good example. And I love how you've solved a problem there, but also the measurable impact that you're able to tell me and everyone listening today. And of course, VMware Cloud Foundation is another key part of this setup. So why was it chosen, and how does it help you standardize infrastructure across so many different Audi plants?
When we started this project, or when we came up with the idea of virtualizing these automation applications, the 5 I told you. Of course, being from production, we talked to our automation colleagues first, and what we heard was, that can't be done. Okay, why not? And in order to virtualize a PLC, and that's the technical most advanced subject, so I'll talk about that application the most. Virtualizing a PLC, you need several things. The first topic we had to manage was preserving all the features of a field bus, tunneling this field bus into a data center. So we went and looked into the networking. How do you preserve Profinet, real-time safety standards, tunnel that through a layer 3 network into the data center, while maintaining this real-time aspect and maintaining the safety aspect of that field bus. And once we had that solved, the question was, okay, and now we need a hypervisor that still preserves this real-time features and the safety features. How do we do that? And that's when we talked with our IT, it's like, hey, we'd like to work with a partner that you've been working with. And IT said, hey, for VMware is our preferred partner. And so we started talking with VMware, our vision where we wanted to go, and saying, hey, we want to virtualize this because we see the benefit of using all those data center features in the automation world. And the colleagues at VMware believed in the same vision, said, okay, let's try this together. Let's figure out what needs to be done to the hypervisor so that this real-time capability is preserved. What do we need in the NSX switch in order to preserve the real-time networking requirements. How do you do that? And so together with VMware and Cisco for the networking part, we worked like on this foundation. And then on the PLC part, Siemens and Coatsys are the PLC partners that developed their PLC software and had it certified to work on this entire setup. So it was really a combination of bringing market leaders together to one table and telling them, hey, listen, this is the challenge that we have. We don't know how to solve it. We're just the metal benders. We want to use that technology because we see that there are benefits in using it, but we need you as the experts to tell us, is this doable? And if it is doable, to solve that problem kind of on the software side so that we can deploy it.
And we are living in a world of sustainability goals and ESG scores, for example. So how has replacing thousands of decentralized industrial PCs with local edge servers, has that affected Audi's energy use, environmental footprint, and indeed overall efficiency? Do you measure that impact?
We do measure it. I cannot give you the numbers, but just for a comparison, I mean, we replace an IPC. And we usually used the biggest IPC we could get so that it lived longer, so we had to replace it later. We replaced it with a standard thin client. There's a big reduction in like all the amount of stuff that goes into building those thin clients in comparison to an IPC. We're able to consolidate 12 PLCs on one server, and that also is a smaller footprint for this one server in comparison to those IPCs. So I can't give you numbers, but yes, that is part of our goal, and also reducing the overall setup uses less energy than the IPCs that we have in our production.
And if we were to look a little further ahead, how do you see smart floor automation and virtualization? How do you see these things enabling maybe new use cases like AI-driven production, predictive maintenance, proactive rather than reactive, or even a wider rollout across the Volkswagen Group? How do you see the future here?
Those are several questions. Let me try to take them one at a time. The concept that we're doing now, we are showing that this is working, and being rooted in production with all the enthusiasm for the new technologies, we want to make sure that we roll something out that's rock solid. So we started with the entire rollout in our Böllingerhöfe plant. And that was the first plant where we transformed the final assembly, and we also have the first VPLC running. And we've shown there that this is running rock solid. So the VPLC in the Böllingerhöfe without safety is running now for over a year. And since March, we have the VPLC with safety up and running, and no glitch, no problems whatsoever. And that said, even so, that we encountered troubles. You know where the phrase computer bug comes from. It was this moth flying into the IBM mainframe, I think at NASA in the 60s. We're trying to coin a new phrase now that's a network beaver. What is a network beaver? Well, a network beaver is a beaver that bites through a fiber optic cable that runs from the Böllingerhöfe plant into our Neckarsulm plant data center. And that actually happened. Beaver bit through that cable, one of the two redundant lines, and all of a sudden one of those lines went dark. I'm like, oh no, what's happening? And the cool thing is production kept on working. So our redundancy concepts worked. One line a complete blackout due to this beaver biting through that cable. And so that was for us the kind of the proof in the pudding that yes, our redundancy concept does work. It's exactly doing what it's supposed to do. We see this major failure on one line. We can get to fix it. Of course, if the beaver would have bitten through the second cable at the same time, then we would have had a problem. But no, our redundancy concept worked, and we have this rock stable production. Now, from there, knowing that this small plant in the Böllinger Höfe with long takt times, and that's why the risk of deploying it there was lower, because we have these long takt times. We are now scaling it to our Ingolstadt plant and to the Neckarsulm plant, knowing, hey, this is working, and now we can scale it to full-blown, high-volume series production. And then from Ingolstadt and Neckarsulm, we'll continue with our plant in Győr and our plant in Mexico. And then we're talking with our colleagues in the VW group how to scale this into the entire VW family for the benefits that this concept does have. I think what I'd like to point towards the future is now that we have this IT hardware consolidation in the local data room, delivering millisecond real-time performance to everything that you have in the automation world. Now we can start thinking about, how does a smart factory of the future look like having scalable compute? Because we can scale compute in the data center much, much easier than we can with distributed compute on the shop floor. And for me, this is a cornerstone to be able to do secure, scalable compute in these local data centers and really drive the idea of the smart factory.
I think that is a powerful moment to end on. There's a lot to see and do here. I know how incredibly busy you are, but just thank you for stopping by and sharing your powerful story today that had everything from emerging technologies to pesky beavers. Thanks again.
Thank you, Neil, for having me.
I think one of the things that struck me most in the conversation there was how Audi's journey wasn't driven by shiny technology for its own sake, but by business cases, resilience, and efficiency. And he reminded us that true innovation isn't about replacing people or reinventing everything overnight. It's actually about finding the right cornerstone that let the factory adapt faster, scale smarter, and waste less. Sounds simple when I say that out loud, but I know it's much more difficult for many organisations listening. But I think the story of virtual PLCs and production clouds, although it might sound niche, it carries lessons for any industry that's wrestling with old systems, legacy tech, and technical debt in a fast-moving digital world. But transparency, standardisation, and a willingness to experiment really can change what's possible. So as we leave VMware Explore, I'm going to leave you with this question. If Audi can reimagine something as complex and ingrained as a car factory floor, what legacy processes in your own world might be ready for a rethink? As always, tech blog writer at outlook.com, LinkedIn, X, Instagram, just at Neil C. Hughes. Remember to check out the Tech Talks Network, techtalksnetwork.com, and let me know your thoughts on everything. But that's it for today. So thank you so much for tuning in, and I'll be back again tomorrow with another guest. Bye for now.